If we look at the occurrence and crystallization of quartz, quartz crystallizes directly from igneous magma. Hence, it is a major constituent of plutonic, hypabyzal and volcanic rocks. It is also a common constituent in sedimentary as well as metamorphic rocks. As per Bowen's reaction series, which can show how crystallization happens in a magma, quartz crystallizes at the end at low temperatures. Quartz is stable under both low and high grade metamorphic conditions. Quartz is also stable in sedimentary conditions either as detrital material or as cement in consolidated rocks. As quartz is so common, it is impossible to enumerate all the places where it is found. It is a major constituent of sand and soil everywhere in the world. Let us see the uses of quartz. Uses of quartz in glass making is a primary consumption throughout the world. Highly pure silica sands are used in the glass making industries. Quartz sand is used in the production of container glass, flat plate glass, specialty glass and fiberglass. Quartz is an excellent abrasive material. Quartz sands and finely ground silica sands are used for sandblasting, scoring cleansers, grinding media and grit for sanding and sawing. Quartz is very resistant to chemical treatment and heat treatment. It is therefore often used as a foundry sand. With a melting temperature higher than most metals, it can be used for molds and cores of common foundry works. Refractory bricks are often made of quartz sand because of its high heat resistance. Quartz sand is also used as a flux in the smelting of metals. Quartz is used in the petroleum industry as sandy slurries in the oil and gas wells. Quartz sand is also used as a filler in the manufacture of rubber, paint and putty. Screened and washed, carefully sized quartz grains are used as filter media and roofing granules. Quartz sands are also used for traction in the railroads or railways and mining industries. These sands are also used in recreation on golf courses, volleyball courts, baseball fields, children's sand boxes and beaches. High quality quartz crystals are normally single crystal silica possessing good optical or electronic properties that make them useful for specialty purposes. In the industries, on an average, about 10 billion quartz crystals are used every year. Optical grade crystals are used as lenses and windows in lasers and other specialized devices. Silica stone is an industrial term for materials such as quartzite, novaculite and other microcrystalline varieties of quartz. These are used to produce abrasive tools, grinding stones and tube mill liners. Tripoli is a crystalline silica of an extremely fine grain size, maybe less than 10 micrometers. It is used for a variety of mild abrasive purposes which include the preparation of soaps, toothpastes, metal polishing compounds, jewelry polishing compounds and buffing compounds. Tripoli is also used in brake friction products, fillers in enamel, plastics, paints, rubber and refractory industries. Quartz minerals show a strong piezoelectric effect perpendicular to the prism axis. Applying pressure on a quartz crystal generates an electrical polarization along the pressure direction. Alternatively, applying an electrical tension leads to a mechanical deformation of the crystal. During the 1970s, the quartz watch entered into the world market as the newest technological gadget. People wondered as why it is called as quartz watch or why quartz watches are so much more accurate than the wind-up watches. There is an amazing electronic phenomena existing in the quartz crystals. Due to that phenomena, it is used in the heart of a quartz watch. During the 1970s, there was a necessity to find out a new timing element and designing an integrated circuit that would use very little power. It was also necessary to allow the watch to run on a tiny internal battery. This was the situation in the early 1960s. There was no problem with the choice of a timing element. The quartz crystal is possibly thousands of times better for timing than the tuning fork, and the quartz crystals have been around for many years. Only the type and the frequency of the crystal needed is to be chosen in this, for which the suitability of quartz has been observed. Quartz crystals have been in regular use for many years to give an accurate frequency for all radio transmitters, radio receivers and computers. Their accuracy comes from an amazing set of coincidences. Quartz, which is silicon dioxide like most sand, is unaffected by most solvents and remains crystalline to several hundred degrees of temperature. The property that makes it an electronic miracle is the fact that when compressed or bent, it generates a charge or voltage on its surface. This is a fairly common phenomena called as piezoelectric effect. In the same way, if a voltage is applied to quartz, it will bend or change its shape very slightly. If a bell were shaped by grinding a single crystal of quartz, it would ring for minutes after being tapped. Almost no energy is lost in this material. A quartz bell, if shaped in the right direction to the crystalline axis, will have an oscillating voltage on its surface. The rate of oscillation is unaffected by any temperature. If the surface voltage on the crystal is picked off with plated electrodes and amplified by a transistor or integrated circuit, it can be reapplied to the bell to keep it continuously ringing. The best shapes are a straight bar or a disc. A quartz bar can be tiny and oscillate at a relatively low frequency of 32 kHz. Modern quartz watches use a low frequency bar or tuning fork shaped crystals of quartz. Often these crystals are made from thin sheets of quartz plated like an integrated circuit and etched chemically to shape them. Quartz is one of the most useful natural materials in the world. Its usefulness can be linked to its unique properties, chemical composition and the specialty features it has, including the gem varieties of quartz occurring in the world. Let us see some more details of quartz in the forthcoming modules.